So in this part of the lecture, we're going to be looking at the sine rule. So the sine rule is something we use when we have non-right angled triangles. So what the sine rule states is that if we have a non-right angled triangle that looks something like this, and we actually have a couple of sides and we have an angle, or we have a couple of angles and a side, it's possible for us to calculate what the other side is in this non-right angle triangle. So the rule itself, I'll tell you, it is A over sine A equals B over sine B, which equals C over sine C. So let's show why that's true. So we can show this proof by using our SOHCAHTOA. So to do SOHCAHTOA, we need to actually make this non-right angled triangle into two right angled triangles. So we can do this by drawing a line down the center. If I can hit the center here, and we know that this is a right angle. So we call the triangle maybe A, B, C, and we can begin to label up our sides. So in the sine rule, what we say, if we have a capital A, the sign which is opposite on the triangle itself would be little a, this would be little b, and this would be C underneath. And this new line that we've drawn, we're going to call this H, and we'll call this point D, so where it intersects or bisects the triangle. So what we can do is we can begin now to work out our cosine rules for triangles A, D, and C. And we can also begin to look at for C, D, and B. So the whole rule is called the sine rule. So it makes sense that we're going to use a sine to be able to help us to do this. So we get our rules, SOH, CAT, TOA, and we have these two right angled triangles. So we're only bothered about this relationship here. So what we can say is, okay, so our hypotenuse on this side has to be A, our hypotenuse on this side has to be B. We want to look at angle A, so that's A here, and we look at angle B, which is angle B here. So that means that the H on both cases would be the opposite. So if we begin to fill out our equation, that sine A for the first one equals the opposite, which is H, over the adjacent, over the hypotenuse, sorry, which is B. And we can see the same for CDB. We see that that would be sine B would equal the opposite H over the hypotenuse, which is A. We then have two equations. So what we can see is that sine A equals H over B, and sine B equals H over A. So here we get some simultaneous equations that we did last week. We can say that B sine A equals H, and we can say that A sine B also equals H. So what we can do is minus these two from each other. So that will give us B sine A minus A sine B equals 0. Or we could say that that would equal B sine A equals A sine B. Or if we just move this one down, we can say that B over sine B equals A over sine A. So that's quite simple and straightforward. And if you were to carry this on, you could do this in your own time. You would actually find for C, if you play with the same relationship with sine, you would get exactly the same. So we would extend our relationship to say that A over sine A equals B over sine B, which equals C over sine C. Okay, so that's quite simple, but it doesn't always work like that. So let's just start with an example of this, and then I'll begin to show you why it's not always that simple. So this is a question you might get in the exam. So it might say in triangle ABC, we might have a side BC, which equals 5 centimeters. The angle A equals 43 degrees, and B equals 61 degrees. So let's draw any non-right angled triangle. So we'll label this up as maybe A, B, and C, and we can begin to add our angles, which would be 61 in this case, and we'd put a 43 in this case. So we'll put also our little a, our little b, and our little c, and we can begin to add on these values here. We've been shown that the question says that it was a to b. Was it a to b? Yeah. Or b to c, I didn't write down. B to c equals 5 centimeters. So b to c here equals 5 centimeters. So now we can begin to fill out our equation. But what we can see is actually we're only bothered about A, and we want to find, the question asks us to find the line A to C, which is our little b. So all we're bothered about is A and B. So we can then say A over sine A equals B over sine B. So if we fill our numbers out, we can see that A is 5, so that would be 5 over sine 43 equals B over sine 61. So if we do a little bit of rearrangement, we can then show that B would equal to 5 sine 61 all over sine 43. And we stick that in our calculator and we get the answer as 6.412. So the answer would be AC equals 6.41 to 2 centimeters to 2 decimal places. Okay, so that's quite a simple case. But as I mentioned, there's always a more difficult case which we can have. So what happens if we have something that looks a little bit like this? So our question might state that we have a triangle, A, C, B. It might also tell us that our side, which is little a here, equals 8. But if it doesn't tell us what our side, it might tell us our side A to B, or little c, equals 10. So our final side equals question mark. If we know that the angle is 20 degrees, we don't actually know what the angle for C could be. But what we can see is, well, if we don't know what B is, then potentially there are going to be 2 answers for C. Because if we were to extend this 8 here and we were to draw it, potentially we could draw the A could equal 8 here, and the triangle, which is going to go way off the paper, could reach something like that there. That's very badly drawn, but it could look like this. So our B could also be up here. So that means there is a potential for 2 answers for our angle C here. Our C here. So let's do an example of this, and I can show you what a question might be like in the exam if you had something like it. So what the question might say is, in the triangle ABC, find C given AB equals 5 centimeters, BC equals 3 centimeters, and A equals 35 degrees. Okay, so let's draw this triangle. So maybe we draw any triangle a little bit like this, maybe a little bit bigger, and we're going to draw it like this, and then we're going to put our letters on. So we can write, here is A, here is B, and we're going to call this C. So what have we been told? So A equals 35 degrees, okay. We've been told that AB equals 5, we haven't been 5 centimeters, we'll just put 5 there for now. And we've also been told that B, our little b, or B to C, sorry, B to C, our little a, equals, we'll put our little c here, little a equals 3 centimeters. Okay, but what we can see is we don't know what this little b is. So again, in the same case, this could mean that because we don't know this angle and we're trying to find C here, there is a potential that this could also equals a second a, which could be 3 centimeters. So we can actually begin to check this. So if we get our sine rule back again, we can say, right, okay, what happens if we have our rule of a over sine a equals b over sine b, which equals c over sine c. And what do we need from these two? Well, we're looking for the side c, so we need c here, and we have quite a lot of information regarding a. So let's fill this in. So we can say that 3 over sine 35 would equal c over sine c. So we have our little c here, which would be, we'd have our little c, where's it gone? We'd have our little c here, which would be equal to 5, and we have our sine c, which is our question mark. So, okay, let's rearrange this. So we would get something that looks a little bit like, we're going to say sine c equals 5 times by sine 35, all divided by 3. So sine c would equal 0.9650. So c, which is the inverse of this, which would be 0.9650, would equal 73 degrees. Okay. So how can we check this? So we could check that this is a potential to have a second answer to it by just checking our angles. So we've got one is 73. So as I told you, all angles in a triangle have to add up to 180. But in this case, because we don't have a right angle, this means that we can occupy this whole 180 segment. So we can say 180 minus 73 equals 180 minus 73 would have to, if we could say 180, what we've got here, minus 73 here, and we can work out the remainder of what it would be, which would be 107 degrees. Okay, so this might mean it might be our second answer to our question. So there's only one way we can check this. So I've told you that we know that sine c has to equal 0.9650. So sine 73 would have to equal 0.9650. So what happens if we were to plug our sine 107 into the calculator? If we were just to check that, we would see that the answer is also 0.9650. So that would mean that there are two possible solutions to the answer. And if you think why that actually happens, and you can see maybe if we look back to the previous lecture, we look at these relationships, what we can see is actually it's just that relationship on the sine which is creating this relationship. But anyway, the answer in the exam would mean that there would be two answers, which would be 0.650 or would be 73 or 107. So C equals 73 or 107 degrees. Okay, so that's the end of this rule. We'll now move on to another rule, which is also great for non-right angled triangles, and this one uses a cosine and